Hi guys, good morning. Yes, can you hear me? Hello.
Yes, sir. Yes, sir.
Yeah, thank you. If anyone unable to hear me, please rejoin the session. Please rejoin. Just rejoin the session. Just rejoin the session. If anyone unable to hear me, just rejoin the session. Okay. Yeah. So thank you guys. So let us start session. Yes, yesterday's session. See, day one, day two introduction. Yes. See, yesterday session Java introduction discussed. Java introduction, like what is Java, different editions of Java, and features, and all of these things we discussed. Okay. Today we'll start with Java features. Yes, main features of Java. Let us start with main features of Java. Yes, main features. Yes, main features of Java. Yes, main features of Java. See here, main features. Yes, independent platform, portability, group language, scalability, and security. These are main features of Java. Let us see one by one. What is independent platform? What is portability? What is group language? Scalability and security. Let us see one by one. Okay. So first one, independent platform. Platform means OS. OS. Java is independent of OS. Same Java program is independent of platform. Okay. Yes, to understand this independent platform, you must hear that OS knowledge, how OS is working, that OS knowledge. We'll discuss now. Okay. Next, independent platform, portability, groups, language. Understand these features. Some basics are required. You need some basic knowledge. So before going to this, we'll see some basics. Yes, to understand these features, some basics required. Yes, like about OS, what is operating system? Yes, about operating system. So about operating system. Yes, about operating system. Next, yes, about interpreter. Next, about compiler. About compiler. Next, about exe file. Yes, and dot class file. So these things, dot class file. These things here. Yes, about system. Yes. So to understand all of these things here, to understand these features here, first of all, some basics required. Basics. To understand all of the features here, they're the features of Java. To understand all these features, there are some prerequisites, some basic knowledge about OS, next about interpreter and compiler. Okay. Next about exe file and dot class files. Yes, next about generation of language. Generation. Yes, generation of languages. Generation of language. Generation of language. Generation of language. Yes. So once you have this knowledge, then easy to understand these features. Okay, once you have this knowledge, then easy to understand these features. So let us start with these basics. What is OS? What is interpreter? What is exe file? What is dot class file? And all this. Okay. Yes. So first of all, let us start with basics. After finishing basics, we'll go to Java features. After finishing all these basics, we'll go to Java features. Okay, right? Yes. Let me open documents or class documents. So this is your Java documents. Yes, Java documents. Yes, 1 second. Why this is a bunch? Just a minute. Yeah, this is the document. So this is Java document. Yes. So let us start with basics here. See, what is software? What is system software, application software? What is OS? What is OS? Next step. Yes, front end, back end, language and packages. Yes, next different low level language, high level languages, generation of languages, interpreter and compiler. After that, about Java. About Java. How Java is working. About Java, next features. That features here, .exe file, class file differences. Okay. Yes. So let us start with all the basics here. So once all these basics completed, then easy to understand Java features. So before going to Java, there are some basics. So once all the basics completed here, okay, you can understand Java features very clearly. So let us start with some basics. These basics, even non-IT background case also can understand. Anyone can understand these basics here. Non-IT background case also can understand. Okay, let us start with basics here. Let us start with basics. Okay, yes. See, I'm starting from very basics. Even non-IT background guys also can understand these basics. See, computerware. Yes, computerware. See, computerware basically two categories. Computerware basically two categories. Basically two categories. First one hardware. First one hardware. Second one software. Hardware and software. First one hardware. Next one software. So what is hardware? What is software? See, hardware. 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 So what is hardware? Yes, these are physical. Yeah, these are physical components of a computer. These are physical components of a computer. These are physical components of a computer. Okay. Yes, hardware. These are physical components of a computer. Okay, physical components. Hardware. Computer basically two categories: hardware and software. Okay. Once again. Yes. So before going to this, all that features here, independent platform, portability, hooks language. First, we have to discuss some basics. Once you have understanding about this here, once you have this knowledge here, then easy to understand this concept here. So first of all, let us say about all these basics. What is OS? What is interpreter? What is compiler? What is exe file, class file, generation of languages? After finishing all these basics, next we'll move to Java. So before going to Java, there are some basics. Before going to Java, there are some basics here. Yes, starting from very basics. Yes, even non-IT. Non-IT background guys also can understand this topic here. Anyone can understand here. See, hardware and software. In computer where basically two categories, here there is a hardware and software. So what is hardware? Hardware. These are physical components of a computer. These are physical components of a computer. Okay. Yes, example like keyboards. Keyboards. Yes, mouse. Yes, next hard disk. Hard disk. Hard disk. These are all the hardware motherboards and all these, right? We can touch all these parts. We can touch all these parts, but this is not our part, but this is not ours. Okay, ours. Ours is a software. Yes, our part is software. So let us start with software here. Let us start with software. Start with software here. So what is software? Yes, software. See, in software, everything is a program. Everything is a program. Everything is a program. In software, everything is a program. In software, everything is a program. In software, everything is a program. Okay. Yes, all are programs. Yes, it's a collection of programs. It's a collection. Yes, it's a collection of programs. It's a collection of programs. It's a collection of programs. Okay, software. Yes, it's a collection of programs. Okay, software. Here, everything is a program. Yes, here everything is a program. Yes, it's a collection of programs. It's a collection of programs. Software. It's a collection of programs. Programs like C. Yes, C++. Yes, Java. Yes, next Python. That is all the programs. All the programs comes under software. Yes, software is a collection of programs. Okay, in software, everything is a program. Yes, it's a collection of programs. Collection of programs like C, C++, Java, Python. Okay. Yes, software basically two categories. Software basically two categories. Software basically two categories. Two categories. Software basically two categories. Software software basically two categories. Two categories. First one, system software. System software. First one, system software. Second one, application software. First one, system software. Next one is application software. Application software. System software and application software. Okay. Software basically two categories. Software basically two categories. First one, system software. Next one, application software. System software and application software. So what is system software? What is system software? Say what is a system software? System software. This one interacts with hardware components. Yes, it interacts. It interacts. It interacts with the. It interacts with the hardware components. It interacts with hardware components. Hardware components. It interacts with hardware components. Okay, system software. It interacts with hardware components. So what is system software? System software. Yes, it interacts with hardware components. It interacts. It interacts with hardware system software. System software. This one always interacting with hardware components. Interact with hardware components. Okay. Yes. Example. Yes. Operating systems. Yes. Operating systems. Yes. Operating systems. Okay. And device drivers comes in this category. Device drivers. Operating systems and device drivers. Okay. So voice and device drivers comes in this category here. Okay, system software. It interacts with hardware components. System software, it interacts with hardware components. Example, operating systems and device drivers. Operating systems and device drivers comes under this category. Alright. Yes, next, application software. What is application software? Yes, application software. What is application software? What is application software? Yes, applications of this is for the yes purpose of application, for the purpose of application development, for the purpose of application development. Okay, application software. So what is application software? Application software for the purpose of application development. Applications. See, apps. So what are the apps? See, in our daily life we are using many applications, right? In our daily life we are using many applications. Yes, anyone, can you tell me some examples of applications? Yes, in our daily life, in our day-to-day life, using many applications. Come on. Yes, guys. Anyone, can you tell me some examples? Applications. Yes, we are using some applications in our daily life, using some applications. What are the applications we are using? Yes, come on, guys. Yes, in our daily life, we are using some applications. You can find Krishna Kishore, Facebook, WhatsApp, Twitter, Amazon, etc. Okay. Yes. Yes, Shake. Okay. WhatsApp, Facebook, Amazon. Yeah, these are the applications, right? You are right. Good. Thank you for response. Yes. Application software for the purpose of application development. Applications. Yes, Facebook. Yes, in our daily life, we are using Facebook, right? Facebook, it's an application. Okay. Next, WhatsApp. Yes. Yes, WhatsApp. WhatsApp. WhatsApp is an application. Facebook, WhatsApp. Yes, next, Twitter, Twitter, Twitter. Okay, Instagram. Yes, all the applications here. Facebook, WhatsApp, Twitter. Yes, some company websites. Company websites. Okay, next, online shopping applications. Online shopping applications. Just like Flipkart and all this here. Online shopping applications. E-commerce applications. Banking applications. Yes, all this. Banking applications. Banking apps. All the apps. Banking applications. Yes, these are the applications. In our day-to-day life here, we are using this much of applications. Yes, many applications we are using in our day-to-day life. Food delivery apps, like this many applications. Yes, even go to training, go to meeting, these are also applications. Applications. Okay. Yes, how to develop this kind of applications here? Yes, how can you develop this kind of applications here? To develop this kind of applications, we need some softwares. To develop these applications, we need some softwares. Okay. Yes, that software is called as application softwares. That software is called as applications. One second. Yes. So application software for the purpose of application development. Yes, applications like Facebook, WhatsApp, Twitter, websites, different websites, company websites, all the applications, right? Yes. How to develop all the applications? To develop all the applications, we need some softwares. Okay, that software is called application softwares. Yes, application softwares. Example. Best example, Java. Java is a mostly used application softwares. In all the application softwares, Java is a mostly used application software because of its features. Java. Next, Python is also application software. C also application software. C++ application software. Yes, next Hadoop. Hadoop also application software. Next, databases also application softwares. Like this, all the application softwares. See exactly what is application software. Let us see. See exactly what is application software. See, in software, many technologies. There are many technologies. Like there are some languages. There are some languages. There are some languages. Just languages like C, C++, Java, Python, HTML, all the languages. Okay, Perl scripting like this, all the languages here, all the languages. Next languages, next there are some tools. There are tools. There are tools like warehousing tools, like Informatica, Ab initio, like this many warehousing tools. Next testing tools like QTP, Selenium, like some there are some tools. Okay. Next, reporting tools like ClipView, Tablet, many tools are in market here. Okay, next, DevOps tools, AWS tools. Okay, like this. So many, yes. So many tools available. Okay, languages, tools, next packages. Package also. There are some packages. Yes, all these application softwares, packages like ERP packages, ERP packages like Oracle ERP, SAP ERP, MS Office also comes in package here. So languages, tools, and packages. All these comes under applications. Simple. There are many things, many technologies in the software fields. There are many technologies. So which is exactly application software? Simple here. Very simple. Except, except, except operating systems, except operating systems, except operating systems, except operating systems, all are application softwares. That's it. Simple, simple points. Application softwares. All are application softwares. All are application softwares. Okay. So except ways, except operating systems. Okay. Except operating systems, all are application softwares. Except ways. So what is ways? Ways comes under what? System software. Ways. Ways is system software. Ways comes under system software. Yes, except ways, except operating systems. Operating system means like Windows is a operating system. Windows is a operating system. Linux is a operating system. Unix is a operating system. Except these operating systems. Except these operating systems, all are application softwares. All are application softwares. All are application softwares. That may be languages, or tools, or packages. Okay. So there are many technologies in market. We have the many software, right? Many technologies, right? Many softwares, except ways, all are application softwares. So it's about application software. So what is Java? Java comes from what? Application software. So our topic is application software. So let us move to application software. See, see document here. One second. See, in documents, very clearly prepared. This document is for you only. Yes, running notes is not necessary. Don't write any running notes. Running notes is not necessary. Just you follow the document. Just you can follow the document here. Okay. See, introduction to software. Software is a collection of programs. Collection of programs such as C, C++, Java, and others. Okay. Next, software basically two categories: system software, next application software. System software and application software. System software, it interacts with hardware components. System software, it interacts with hardware components. Device drivers and operating systems. Device drivers and operating systems. Yes, application software for the purpose of application development. Example, these are examples, right? Okay. See, except ways. Except ways, all are application softwares. So these things we have discussed. So till now, what we have discussed, everything is a document here. Very clearly prepared in documents. You can follow simply just you can follow document here. So running notes is not necessary. Okay. So Java comes to the application software. So before going to application software, let us see something about OS. Yes, that OS knowledge. Okay. Yes, about let us see something about OS. What is OS? Okay. So you can Java is a application software. So before going to application software, let us see something about OS here. What is OS? About OS. About OS. Okay. Yes, about OS. See, operating systems. Okay. Yes, here some question for you guys. Some question. Some question you have to answer. Some question. Simple question. Very simple question. Very simple question. Yes. Can we run any program? Any program without OS? Can we run any program without OS? That's a question. Yes. Anyone, can you answer this? Yes. Simple answer as yes or no. Answer is very simple. Yes or no here. Here question is, can we run any program without OS? Can we run? Can we run? Can we run any program without OS? Can we run? Can we run any program without OS? Say yes or no. Can we run any program without OS? Say yes or no. Let me check answers. Yes, most of the guys saying that no, 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 no. Yes, can we run any program without OS? Say yes or no. Yes. See, Hans no. So yes, software programs compulsory OS requires. Suppose hardware programs means hardware related programming like traffic signals programming. Next, the microcontroller based programming. Microcontroller based program, that case OS is not required. Microcontroller based programming like remote controllers, TV remote, car remote. Next, traffic signals, washing machine timer. Those are running based on microcontroller. Microcontroller programs OS is not required, but software programs. To run the software programs, compulsory OS required. Without OS, we can't run any compulsory OS requires. Okay. Yes. So a simple question is, can we run any program without OS? No. Software programs we can't run. Compulsory OS required here. So what is operating system? 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 Let us see about OS. Okay. So what is OS? See what is OS? Let us see about OS here. What is OS? What is OS? See, hardware. Yes, suppose when you purchase your laptop, when you purchase laptop here, with your laptop getting OS also. That laptop vendor who are selling laptops, laptop vendor, yes, will set up the OS also with OS getting. So hardware on top of hardware OS, operating system, operating system. On top of OS, this operating system. Yes, on top of hardware, there is a OS. So once OS setup is done, your system is ready. Once OS setup is done, once OS setup is done, system is ready. So one system is ready here, then you can use. Okay, see, this is my system with OS, right? This is with OS. My system with OS. Understand? Now this OS is responsible. This OS is responsible. This OS is responsible to run any request here. Suppose Eclipse. So once I double click on this, OS is responsible to launch the Eclipse. So putty, OS is responsible to launch putty here. Yes, VirtualBox, like this different kind of things. When I click on this, OS is responsible. So every request goes to OS. Every request goes to OS. Okay, every request performed by OS. Okay, suppose learning some C language. Suppose learning some C language. Okay, so first of all, you have to install C software, right? Suppose learning C language, C software you have to install. Suppose learning C++, that C++ you have to install. Suppose learning Java, Java you have to install. Okay, suppose learning Hadoop, yeah, Hadoop software you have to install. Suppose using some database, the database software you have to install. Yes, all these are called as application softwares. All these are called as application softwares. Application softwares. All they're called as application software. Okay, C, C++, Java, Hadoop, database, maybe Python. Yes, all are application softwares. All the application softwares running at top of OS. All the application softwares running on top of OS. 1 second, let me have some more. Yes, these all are application softwares. These application softwares running on top of OS. Running on top of OS. So without OS, these programs cannot run. Without this OS, these programs cannot run. All the programs, all the application softwares running at top of OS. Okay, fine. That means here OS just it's giving platform. So OS just it's giving platform to run all the application software. softwares. So OS just it's giving platform. So OS is giving platform to run all the application software. Just it's giving platform. Just it's giving platform to run all the application softwares. That, that means OS acting like a platform. It's like a platform. So here OS is acting like a platform. So OS is acting like a platform. Okay. So OS is acting like a platform. It's like a platform. Okay. It's like a platform. On top of it, all are running here. OS is acting like a platform. 1 second. Some guy is facing some machine lining. Yes. So OS. On top of OS, all are running here. All are running. So it's acting like a platform. So it's acting, the OS is acting like a platform. On top of it, all are running, right? So what is OS means? Simple answer. Simple answer. Yes, it's a platform. What is OS means is a platform. It's a platform. It's a platform. Yes, OS is a platform. Simply OS is a platform. It's a platform. So what is OS? Simple answer, it's a platform. It's a platform. Yes, where we can run all the application softwares, all the application softwares, all the application software. Okay, it's a platform. Okay, so what is OS means? Simple answer. What is OS means? Simple answer. It's a platform. OS is a platform. On top of it, all application software will be running here. Okay, it's a platform where we can run all the application softwares. Okay, fine. Yes, next here. See here, not only platform here, not only platform. Suppose C program generating some output. That first of all output delivers to OS. From OS to output device. So we're reading from the keyboards. Keyboard data goes to OS to all of the programs. Yes, application softwares, programs, maybe C program, or C program, Java, Hadoop. Yes, all the programs. These programs generating output. These programs generating output. So that first of all output goes to OS, output delivered to OS. So all the programs generating some output here. So first of all output delivered to OS and then transfer to output device. Suppose reading from the input device, maybe keyboard. So first the keyboard data goes to OS, OS to application softwares. So between application software and hardware, they say OS. So means that means like a mediator. So OS is like a mediator between application software and hardware components. It's like a mediator. Yes, OS. OS is like a mediator between application software and hardware components. So exactly you can say interface. Exactly meaning it's interface. It's an interface. It's an interface. So OS is an interface. OS is an interface between application software and hardware components. So next point. Yes, it's an interface. It's an interface. It's an interface. It's an interface. It's an interface between. It's an interface between. Yes, application software. Yes, application software, and hardware components. Hardware components. That's it. Okay. So what is OS? So first point, it's a platform. So OS is a platform, on top of which all are running here. Next, it's acting as interface. It's acting as interface between application software and hardware components. It's an interface. It's an interface between application software and hardware components. Hardware components. Hardware components. Okay, fine. Next, one more important point. Yes, in Java perspective, one more important point here. See, every OS has its own library. Every OS has its own library to communicate between application software and hardware components. Every OS, every OS has its own library. Every OS has its own library. Its own library. Yes, to communicate between. Yes, to communicate to communicate, yes, to communicate, to communicate, yes, between application software and hardware components. So ways using yes, libraries. So ways using library. So what is exactly library? Library contains all the functions. Library, library is a collection of functions. Library is a collection of functions. Library is a collection of functions. Library contains all the C language functions. See ways developed in C language. Linux ways, Windows OS, Unix OS, all the operating systems were developed in C language. All the operating systems were developed in C language. So these are C language functions. C language functions. So ways using that C language functions to communicate between application software and hardware components. Library. Library is a collection of functions. Library is a collection of functions. Okay, every ways has its own library to communicate between, yes, to communicate between application software and hardware components. Okay, yes. See here, C program or C plus plus Java, something like this. They are different programs. Okay, so here every program before going to start execution, first of all these programs linking with the library, OS library, half linking with OS library and communication with hardware components. So every program has to link with OS library before going to run it. Okay, so before going to run it here, maybe C program or C plus plus Java Hadoop, something like this. These programs, first of all, links with OS library, half linking with OS library, then communicates with hardware components. So every application software program has to link with OS library before going to run it here. Okay, suppose C and C++, exe files, it's a static linking. Java and Python is a dynamic linking. Yes, static linking, dynamic linking we'll discuss next. Wait, static linking, dynamic linking we'll discuss next. Okay, see here every program, maybe C program, or C++, Java, Python, these programs, every program every program has to link with OS library. So every program has to link with OS library to communicate with hardware components. So first of all the programs linking with OS library, all of the programs linking with OS library, half linking with OS library, then execution starts so that it communicates with hardware components. Okay, yes, every program, yes, every program, yes, 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 every program has to link. Every program has to link with OS library. OS library. Every program has to link with OS library. Every program has to link with OS library. Yes, before going to start. Before going to start running here. Start running. Before going to start running here. Before going to start running, correct? Yes, every program it has to link. Okay, yeah. Java point of view, this is very important. Fourth point, every program has to link with OS library. That linking, suppose if it's C and C++, it's a static linking. Java and Python is dynamic linking here. Static linking, dynamic linking, we'll discuss next. I'll explain. Wait. Okay, so these programs linking with OS library. Suppose Java program, before going to run it here, first of all linking with OS library. In Java, there is a JVM. Java, this JVM. JVM links your Java program with OS library of linking the execution. The topic we'll discuss next. The topic. Next coming topic. Yes, immediately next coming topic that is. Okay. So this is about OS. Yes, enough. This OS introduction. Okay, introduction. OS introduction. If you have this knowledge, then easy to understand independent platform. Okay. Yes, to understand this one here. First one, independent platform. Independent platform portability. To understand these features here, to understand these two features, this OS knowledge required here. Okay. So what is operating system? What is OS? Simple answer. It's a platform. It's a platform. On top of it, all the application software is running. It's a platform where we can run all the application softwares, acting like a platform. Not only platform here, it's acting as interface. Acting as interface between application software and hardware components. hardware components. Okay. Next, every OS has its own library. Every OS has its own library to communicate between application software and hardware components. So OS using library, OS using library, just it's using library to communicate between application software and hardware components. Okay. Next, one more point here. Yes, every program, maybe C program or C plus Java, all the programs how to link with OS library. Half linking with OS library then communicates with the hardware components. Yes, compulsory this is. Okay, every program has to link with OS library before going to start running, before going to running here, before going to start execution, before going to start execution, linking. Get that linking can be statically linking or dynamically linking. Statically or dynamically. Suppose if C and C plus statically linking, Java and Python dynamical linking. Yes, we'll discuss. Wait. That point also I'll cover. Okay. So this is about OS. This is about OS. Okay. Yes, enough. This introduction is enough about OS. Okay. Right? Yes. 1 second. Let me have some water. See the document. In document also same thing explained here, but OS. It's a platform that all the points in document also very clearly explained here. Hardware, on top of hardware, this OS, on top of OS, application software, all this. Yes, in document very clearly mentioned. So this is about OS. Now, Java comes under application software. Java is application software. So let us move to application software. Java is application software. Application software. Java is application software. Application software. See, in application software, basically two categories: front end and back end. Front end software and back end software. So, what is front end? What is back end here? Front end, back end. 1 second. Yeah, this is called as front end. Suppose we are filling some details, right? First name, last name. See here, first name and last name. Next email address. So next phone number, like this, right? We are filling this information and register. Yeah, this is called as front end. This front end taking data from you, right? This front end. This is called as front end. It's user interface. Okay. Yeah, this is taking data from you. Yeah, this is taking data from us. This is called the front end. So front end interact with the end users. We are the end users. We are the end users of this application here. Go to training application. We are the end users. End users. Okay. So now this front end, this is taking data from us. Just it's taking data from us. Filling this information, register. Once registered, this information storing some location. All this information storing at some location. That location is called as back. Okay. So front end interact with end users. This is called as front end. Front end interact with end users and collecting data from end user. Collecting data from end user. After collecting, storing some location, that location is called as back end. Back end. So front end interact with end users. Back end is to store the data. Front end interact with end users. Back end is to store the data. That's it here. Okay. So front end, back end here. Front end. See this front end. Yes. These are to interact with the end users. End users. It collects data from end users and stores in the back end. Okay. So end users. We are the end users. So we are filling this form, right? We are supposed. So we are the end users. We are the end users. We are the end users. Okay. So front end taking data from end users. Front end. Yes. These are to interact with the end users and collecting data from end users stores in the back end here. So what is back end here? Back end. These are used to store and maintain data. Back end examples, databases and files. In databases, servers you can store data. In files also you can store data. These are the called backends. Okay. Yes, Java comes on the front end. Java is a front end. Okay. Sorry. Front end. So Java comes on the front end. So let us move to front end. In front end, there are some language and packages. Language and package here. So package means ready-made one, ready to use. MS Office is a package. Yes, ERP package like SAP ERP, those things here. Tally accounting pack, they are the packages. These packages are ready to use, ready-made and ready to use. No programming, nothing. No programming. Programming is not required. Here, programming is not required. Programming is not required. Directly using just languages. Yes, in language we should write coding. We should write the programming here. In language we should write the code. Programmer has to write the codes. Okay, Java comes in languages. Java comes in language. So our topic is language. Let us move to languages here. What is a language? Okay, yes. So what is language? Let us see what language. What is language? Okay, see the way of introducing into Java. Try to observe it. The way I'm introducing here. Computerware. Computerware, hardware, software, right? Our part is software. So start is software. Software. In software, basically two categories. Okay, system software, next application software. Okay, Java comes with application software. So move to application software. Application software. In application software, they say front end, back end. Front end, back end. So Java comes on the front end. So move to front end. In front end, languages and packages. Java comes on languages. Now moving to languages. Languages. Let us say about languages. Okay. Yes, let us say about language here. So languages. Yes, what's a language? What is a language? Simple question. What is a language? See, we are speaking many languages. See, we are speaking many languages like English, Hindi, maybe Telugu, Tamil, Malayalam, Kannada, something like this. There are different languages we are speaking. Why? What is language? Why you speaking all the languages? Just expressing your ideas, right? For expressing your ideas, we are using some language. So these all are just a media of communication. Language, just it's a media of communication between two things, right? Yes, media of communication. Language is a media of communication between two living things. Maybe two persons or two animals, two trees. Okay. Yes, every living thing has its own language. It's a media of communication between two living things. Okay. Yes, come to software. See in software. See computer. See computer. Computer understanding some language. What is computer understandable language? Computer understandable language. Computer understandable language. What is computer understandable language? Computer understanding some language. What is computer understandable language? Binary code. Zeros ones format. It's a binary code. Computer understandable is a binary code. It's a binary code. Binary code. Computer understandable language. It's a binary code. Okay. Yes, called as yes, system understandable language. System understandable. System understandable. Understandable. System understandable language. System understandable language. System understandable language. System understandable language. Okay, system understandable language. It is in the form of binary codes. It is in the form of system understandable language. It is in the form of binary codes. Binary codes. Okay. Yes. It is called as machine language. Yes. So this is computer understandable language. Next, one more here. We are understanding some other language. This is computer understandable language. That's okay. We are understanding some different language. What is our language here? What is our language? For example, here, for Java program. Let us take Java program. See, suppose Java program. Suppose this is Java program. Yeah, this is like English language, right? Java program is looking like English language. It's English language. Java program like English language. Like English language. Okay. So let us take Python. Python script. So Python. Python. So Python. Python. See Python. This sounds like English language. This sounds like English language. This sounds like English language. Let us take some C program. Even C program is also like a English language. C program. Suppose C program. Suppose some C program. This sounds like English language. Okay, these are user understandable languages. User understandable in the form of English language. User understandable. User understandable like English language. User understandable like English language. So next, user understandable. User understandable. User understandable. Understandable. Yes, it's English language. Just it's English language. Just it's English. User understandable language. User understandable language. It just it's English. It's English, right? So computer understandable language called as low level language. User understandable. User understandable called as high level language. So in languages, basically two categories. First one, yes, low level languages, low level languages, low level languages. Second one, yes, high level languages, low level languages and high level languages. Okay, first one, low level languages. Second one, high level languages. Okay, low level languages. Next, high level language. So what is low level language? Yes, languages. In software language, basically two categories. First one, low level languages. So what is low level language? Low level languages. Low level language. Low level language. Okay. Yes. It is a system understandable language. System understandable. It is system understandable. Understandable. It's a system understandable language. It's a system understandable language. It's a system understandable language. Okay. Yes. It is in the form of form of binary code. It is in the form of binary code. It is in the form of binary code, like a zeros ones format, like a zeros ones format. Okay. Yes. Low level language. Yes, it's a system understandable language. It is a system understandable language. It is in the form of binary code. System means is a processor. System means a processor. System means processor. It's a processor. System is processor, like 8086 processor here. Nowadays we are using 8086. 8086 processor. Now we are using 8086 processor. Yes, processor based computer. Now we are using processor based. 1 second. Processor based computer. Yeah, this is processor based computer, fourth generation of computer. How many generation of computers? Simple question. How many generations totally? How many generations? First generation, second generation, next third generation, the fourth generation, and fifth generation future. First generation, some vacuum tube, yes, vacuum tubes. First generation. Okay. Next, second generation, printed circuit boards, integrated circuit boards. Like this, there are different generations. Now, present generation is fourth generation. Fourth generation. Yes, processor based. It's a processor based computer. Okay. Yes, fifth generation. So next coming generation. Yes. Can you guess it? Can you tell me? Yes. Yes, next generation. Now presently we are using processor based computer. Now which one coming in future? Fifth generation. No idea. Yes, shortly coming to the market. Now presently processor based computer we are using. In future, shortly coming, maybe couple of years, maybe 2 or 3 years, coming that computer. Yes, AI computer, artificial intelligence, AI based computer. Okay. In place of processor, artificial intelligence. Okay. Artificial intelligence based here, AI based computer here. Artificial. Okay. Artificial. Yes, artificial means this will identify everything automatically here. Processor means if it is processor based computer, we have to write the program, we have to submit the program. Yes, processor based, if it is processor based, we should write the programming and we have to run it here. But artificial intelligence based computer here, that will identify every activity automatically without writing programming. Without writing programming, that can identify all the activities automatically. That is AI based. Not at released here. Future. Yes, maybe taking some time. 3 or 4 years. Presently, it's a fourth generation. Fourth generation computer. Presently, we are using fourth generation computer, processor based computer. In future, fifth generation AI based, artificial intelligence based. In future, okay. Yes, yes, you can check it. Generation of computers. Generation of computers. Generation of first generation vacuum tubes. Second generation transistor based here. Third generation, yes, integrated circuit board based. Okay, IC based. Okay, next fourth generation processor based. So next fifth generation, one more row. Say this is fifth generation. Yes, AI, artificial intelligence based. Fifth generation. So first vacuum tube. Yes, see this vacuum tube. Okay, vacuum tube. First one. So next one is second generation computer. Second gen transistor based. Third generation. Third generation. Yes. One second. So third generation. Yes. IC boards. Integrated circuit boards. Fourth generation. Now we are using processor based. Processor based. Processor based here. It's a processor based. So microprocessor based. It's a processor based. Yes. 1970s to present. Next future. In future, yes, fifth generation. It is in future. Present and future. Fifth generation computer. It's AI. Artificial intelligence based. In future, that's a future computer. Okay. Yes, now processor based. Yes. Now it's a processor based. Okay. Yes. System is now it's a processor based. Now we are using 8086. That basics. Yes, you must have this knowledge, guys. When you are a software engineer, right? That how many generation of computers, what are generation of computers used. These all are basics. Okay. Lot of knowledge you have to. Okay. Yes, you have to gain lot of knowledge. Yes, always you have to work on. Yes, Google getting a lot of information. You have to gather all the information. Okay. Yes. So low level languages. Okay. So low level languages. Yes, this is a system understandable language. It is in the form of binary codes. System is it's a processor. It's a processor based computer. Now currently we are using processor based computer 8086 processor. 8086 processor. It's a processor understandable language. So what is low level language? It's a system understandable language. Okay, right? Next high level languages. High level. Yes, high level languages. High level. Yes, it's a user understandable language. High level. Yes, it's a user understandable. Yes, it is a. Yes, it's a user understandable. User understandable language. It's a user understandable language. Okay. Yes. Yes. High level language. It's a user understandable language. Yes, it is in the form of. Yes, it is in the form of. It is in the form of English language. It's like English language. Like English language. It is in the form of English language. Like English language. Yes, it is like English language. It's like English language. Very easy to understand. It's like English language. Okay, C program, C++, Java, all are high level language. C is a first to high level language. C is a first to high level language. C language. C language is a first to high level language. Later other languages. C is a first high level language. Okay. Yes. High level language. It's a user understandable language. It is like English language, like English language. Yes, it is very easy to understand. It is very very easy to understand. Easy to understand. Fine. So these are in software. There are two categories of language: low level languages and high level language. Low level and high level. Low level language and high level language. Low level and high level. Okay, fine. See, suppose Python scripter. It's a high level language. C program. It's a high level language. Yes, next Java program. It's a high level language. Java program, high level language. Now this high level language has to convert into binary code. System cannot understand this language. This high level language code, this high level language code, this high level language code has to convert into binary code. Who will convert it? Yes, who will convert? Which one will convert from high level language to low level language? Which one will convert? Which one will convert from high level language to low level language? Which one will convert from high level language to low level language? Yes, compilers. Compilers and interpreters. Okay. Yes, interpreters. Yes. Interpreters, 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 and compilers. Interpreters and compilers. Interpreters, compilers, converts, 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 converts from high level language. Interpreter and compilers. Okay. See this. Interpreters, interpreters and compilers. Interpreters and compilers converts from high level language to high level language. High level language means your Java program, hard C program, just high level language. High level language to low level language. Binary codes. Binary codes. Okay. So either interpreter or compiler converts from high level language to low level language. Low level language. Low level language means binary codes. Binary codes. Okay. Yes. So what is interpreter? What is compiler? This is very, very important topic for Java. To understand Java, yes, you must have this knowledge. What is interpreter? What is compiler? This is minimum knowledge. Every software engineer must have this interpreter and compiler. Yes. What is interpreter? What is compiler? Java depends on what? Is it interpreter based or compiler based? We should discuss the topic here. Interpreter and compiler. Difference between interpreter and compiler. Yes, anyone idea? Can you tell me some idea about this interpreter and compilers? Of course, I'll explain. I'll explain. Don't worry. Just I'm asking your idea. What is interpreter and compiler? Yes, what's the difference? What's the main difference between interpreter and compiler? What's the difference between interpreter and compiler? Anyone? Anyone? At least 1 point. Yes, at least 1 point. No one? No one answering? Suresh. Yes. Compiler converts entire code. Okay, fine, good. Next, any other difference? Interpreter. Next, others. Come on, guys. What is interpreter and compiler? Basic knowledge, minimum knowledge. Who completed C language? Who learned C language? Yes, compulsory. Yes, they'll be having this knowledge. Interpreter and compiler, what's the difference? Okay, I'll explain. You don't worry, guys. Interpreter and compiler. Interpreter versus compiler. Let's see about this. Yes, what is interpreter? What is compiler? Interpreter versus compiler differences. Let us see the differences. Interpreter versus compiler. What's the difference? Let us see. First, let us take interpreter. Interpreter and compiler both are converting high level language to binary code. Both are doing same job, but way of working is different here. Both are converting from high level language to binary code, but the way it's working is different. Yes, let us see interpreter. The interpreter based language, Python. Let us take Python. Okay, so some Python source, some source code file, source code. So what test.py, Python script. Let us take some Python script. Okay. Yes, I'll show practically so you can understand clearly here. Not theory explanation, practically I'll show. Okay. So practically we'll discuss how interpreter is working. Practically, I'll explain. Suppose interpreter based. So Python script. Let us take some Python script here. D drive, mn Python folder, D drive, mn Python. In this folder, here this is some test script is there. Test script. So D drive, mn Python. So command prompt. Yes, go to command prompt. Command prompt. Okay. D drive. Go to D colon to go to D drive. Der. That output. Der. So the disk contents. Der output here. Here they say yes. Yes, mn Python. Mn Python. Mn Python directory. CD change of directory. Yes, mn yes, mn Python. Mn Python changed. CLS der. Okay. Now here they say test.py Python script. Test.py notepad. Test.py. Yes, open. Yes, this is a Python script, right? How it's working. Okay. See A equal to 10. Very simple program. A equal to 10, B equal to 20, C equal to A plus B. Yes, addition equal to displaying C value. Next C equal to A minus B. Subtraction, multiplication, all this. Save. Exit. Now run it. Yes, Python interpreter. Now Python interpreter. Python. Yes. Now Python interpreter taking Python file and executing. Run it. Enter key. Run it. Yes. Addition, subtraction, multiplication. Addition, subtraction, multiplication. Right. Top to bottom. So one by one statement executed. Okay. Suppose some mistakes in the program. Suppose here some mistake. Comma missing. Here comma missing. Suppose here double quotation missing. Suppose here bracket missing. What happens? Let's see. Control S saved. There are three mistakes, three errors. Then how it's working? Let us see. Three errors. How it's working here? Okay. No run it. Yes, directly running. Yes, Python script running directly. It's the interpreter based. Direct running. Suppose if it is compiler based, first of all you have to compile it, checking for all errors. If it is compiler based, first of all checking for errors. Yes, C program. First of all you have to compile it, right? After compilation, if no errors, you have to run it. C program, first compilation. If no errors, you have to run it. But when come to Python, directly running here. Error checking not necessary, directly running. See, I'm running directly here. See this error at 7th line. 7th line. So at 7th line, I write and stop. It's not checking for next errors. Next coming errors. Yes, actually there are three errors. In script there are three mistakes, but showing only one error. So what happens here? Interpreter based. What happens? Let us see. Interpreter based. What happens here? See. First statement. So first statement. Okay. Next statement. Okay. Yes. Next statement. So next statement. Yes. Next statement. There are some statements here. There are some statements. Interpreter based. There are some statements. Okay. How it's working here? Yes, interpreter checking for the first statement. So first statement is correct. So for example, here Python A equal 10. Statement is correct. 1 second. Exit. Let me open recent file. Yes. Now this is A equal 10. Here this statement is correct. What happens? Immediately executes. This A equal to this statement converts into binary code and executes. Once executed, allocating memory for A, storing 10. Next A, B equal to this statement is correct. Simply converts into binary code, executes. Once executed, memory allocation for B, then storing 20 here. So statement is correct. Syntax is correct. Simply executes. Means allocating memory for A, storing 10. Next, allocating memory for B, storing 20. Next, this statement also correct. This statement also executes. Then A plus B calculating and storing variable C. Variable C, right? Next state. Now checking for this here error. Simply stop. Error coming here. So once error comes, simply stops. Here stopped here. Here stopped. Okay. See here how it's working here. Checking for the first statement. Suppose first statement is correct. immediately converts into binary. The statement converts into binary codes. So first statement converts into binary code, zeros ones formats, converts into binary codes. The statement converts into binary code, just to convert into binary codes. Okay, first statement is correct, converts into binary codes. Okay, after that, yes, submit to processor generating output, simply generating output. So next, after see, yes, first statement is correct, immediately converts into binary code, generating output. Next statement may be right or wrong. Interpreter never looking for next statement. If that statement is correct, immediately executes. Checking for next statement. Checking for next statements. Suppose next statement is correct, same. Next statement is correct, same happens here. It happens same here. Next statement is correct, same. Same here. Next statement is correct, same here. Suppose next statement. Suppose something wrong here. Something wrong. Something wrong simply stops. Yes. If any error comes, simply interpreter stops. Yes, it won't check for next coming statements. No, maybe right or wrong, never. Yes, first statement is correct, immediately executes. Next statement is correct, immediately executes. Means line by line. Line by line. So interpreter checking line by line and execution. Checking first line, then executions. Checking second line, then execution. Checking third line. So error. Error at some line. So once error comes, simply stops. This is working of it. Yes, if any error comes, interpreter stops. If any error comes, interpreter stops. This is working of interpreter. Okay. Yes, see this. Here, what is happening here in this? Yes, error. Seventh line error, right? Seventh line is so stopped here. Stopped. Now let us correct that mistake here. Seventh line. So this is seventh line mistake. Comma placed. Save. Save and exit. CLS now. Right. Yes, now 11th line error. So here only one error is not showing next coming errors. Only one error. Yes, interpreter shows only one error. Interpreter shows only an error. Only one error. If any error comes, simply stops. If any error comes, simply stops here. So stopping here. So only one error. So correct this mistake also. Yes, mistake corrected. Save. Save. And run it again here. Again, see. Next. Again, 70th line error. 70 line. So like this. So line by line this is. Okay, any error comes, simply stops here. Any error simply stops. It shows only one error. It shows only one error here. So here it shows only one error. Yes, serious. Yes, fine. This is about interpreter. Okay, so interpreter checking first statement. Interpreter checking first statement. If first statement is correct, immediately executes, generating output. Second statement also correct, immediately executes. Suppose something wrong here, simply stops. Something wrong, simply stops. Simply stops. It shows only one error. It shows only one error. Yes, if it is compiler, how it's working. Let us see about compiler. For the compiler, let us take C program. For compiler, let us take C program. C program. Yes, Linux. Linux based. I'm starting Linux based. Yes, how to develop Java programs in Linux, that also we'll discuss. Java program in Linux based, Windows based, Linux based, both we'll discuss. Nowadays, Linux is hot cake. Everyone required Linux knowledge. Yes. Compiler. Compiler. Support.c file. Test.c. Yes, how compile is working? Test.c. How compile is working? See. Yes, compiler. Suppose C program. How compile is working? C program. Yes, compiler checking for the first statement. Suppose first statement is correct. Even it's correct, it won't convert into binary code immediately. No, it won't convert. It won't convert into binary code immediately. Next checking for next statement also. Suppose next statement also correct. Even it's correct, it won't convert into binary code immediately. Okay. Suppose next statement some error. Error yet third line. Error yet third line. After checking for next statement also. Even error comes, it goes to next statement. So compiler checks whole program from top to bottom. Checking complete program from top to bottom. Compiler checks whole program from top to bottom. and shows all the errors. Error at some sixth line. Okay. Yes. Checking next one. Checking next one. Checking next one. Checking next one. Suppose something wrong. Error at some line here. So checking next one. Okay. Checking next one. So top to bottom. Compiler checks the whole program from top to bottom and shows all the errors. All the errors. All the errors. Okay. Yes. Compiler checks whole program from top to bottom and shows all the errors. Shows all the errors. Okay. Suppose. Yes. Correction of errors. Yes. All the errors. No correction of errors. As a programmer, you have to correct all the errors. Correction. Suppose this correction is done. Yes. Suppose this correction also done. So top to bottom, no errors. Everything is fine. Recompilation. On recompilation, no error message. Everything is fine. Everything is fine. What's next step? If no error message, what happens here? If no error message, what happens here? Compiler opens another file. If no errors in the program here, then compiler opens another program file here. Another file here. Compiler opens another file. It opens another file here. Okay. If no errors, yes, compiler checks the whole program from top to bottom. Compiler checks whole program from top to bottom. If no errors here, all the statements converts to binary format and write to another file here. This file here. Write to this file. Okay. Yes. Write to another file. Write to another file. So write into another file. Binary codes. Okay. Every statement converts to binary format. All the statements, top to bottom, all the statements converts to binary formats. All the statements converts into binary formats. Okay. Converting to binary formats. Converting to binary formats. Write to another file. Write to another file. Write to another file. This file is called as exe file. Exe file. Exe means executable file. Ready to execute. Exe file is a system understandable language. Yes, exe file. Yes, more about exe file I'll explain. Wait, I'll explain. So compiler generating one exe file. So compiler checks whole program from top to bottom. If no errors, it generates one exe file. Now this exe file submitted to processor. That exe file submitted to processor. So processor taking that exe file and executing generating output here. So this is main difference. Main difference between compiler and interpreter exe file. Compiler generates exe file. Interpreter don't have exe file concepts. See, interpreter request directly what source code executes. See, Python scripted. Directly source code executed. No exe file. Directly source code executed. Directly source code executed. No exe file concept. When come to C language, C is a compiler based. What is Java? We'll discuss next page. Next topic is about Java only here. C is a compiler based. Yes, let us see how compiler is working. How compiler is working. Yes, how compile is work. Let us see about compiler here. Yes, ls cd mnref. Yes, it's a Linux base here. Yes, you guys don't worry. Our topic is not Linux base. Our topic is about compiler. Okay, just to try to understand about compiler here. Okay, just to try to understand about compiler. Okay, yes, ls remove star. Yes, all files removed. Continue working directory. mnref directory is no files. Gedit like a Windows notepad. Like a Windows notepad, Linux is a gedit. Gedit test.c. Yes, like a Windows notepad, this is gedit. G-editor, this is editor, notepad. Open. Yes, you are writing some C program. Hash includes std io.h. std io.h. So white main function. Yes, starting ending. Main function starting ending. Okay. Yes, this int a is equal to 10. Same addition, subtraction, multiplication, same program in C language. B equal 20. Next int C, int variable C, int C. Okay. Yes. So A equal to 10. Yes. B equal to 20. Yes. C. Yes. C is the result variable. C equal to A plus B. A plus B. Okay. Now printf. Yes. Printf. Yes. Addition. That addition is equal to /d /n comma c, displaying c value. So this addition value, addition. Okay. Yes, addition. Next subtraction. A minus B. Subtraction. Subtraction. Okay. Yes, next. C equal to A into B. Multiplication. Yes, multiplication. Multiplication equal to this is. Okay, so addition. Yes, next subtraction. Next multiplication. Okay. Yes, save. Save. And let's check it. Test.c program. Now this program you have to compile. First of all, you have to compile. Directly you can't run. Compiler based you can't run directly. Interpreter based means directly running. But compiler based, first of all, you have to check for the compiler. Comparison errors. Checking for errors. GCC-C test. Just it's a comparison. GCC, it's a C language compiler. C language compiler. Okay. Yes, compiled, no error. Some test.o file generated. Now this one has to convert into exe format. GCC-o. Yes, exe name is, let us say, project test.o. The tested.o file convert into exe file. Yes, got the exe file. Yes, project exe file got it. We got one exe file. Exe file, project exe. Yeah, that exe name can be anyone. Yes, just given project exe name. / projects. Now running that exe file. Yes, that project. See, what's a type of that project file here? See, project. See, executable file. Okay, 64-bit executable file. See, x86 means 8086 processor. Yes, now we are using 8086 processor. 64-bit OS this is. What is 64-bit is OS. 64, yes, this exe file generated on 64-bit OS for the processor 8086. For 8086 processor, it was generated. It's Linux OS. So this is exe file. So here, so getting one exe file and generating, yes, executing that gret project exe file. Open that. You can see that exe file. Exe file. I'm opening exe file. It will take little bit time. Yeah. See that exe format, binary code. Zeros funds format, binary code, completely binary code. It's exe format. It's exe file. Exe format is like this. It's exe file. So compiler generating one exe file, then executing it to find 1 second. Suppose there are some errors. Gedit test.c. Let us take some mistakes here. Let us make some mistakes here. Semicolon removed here. Suppose here plus don't have. Suppose here comma remote. Next here semicolon. Yes, here double quote missing here. Suppose here, yes, bracket missing. Save. Yes, there are many errors. Many errors. Now how it's working here? GCC -C. C means compilation. GCC -C means only compilation. Compiled. See many errors. 10th line error, 12th line error, 14th line error, 18th line error, 20th line error. All the errors from top to bottom. Right? Compiler shows all the errors from top to bottom. Compiler checks all the statements from top to bottom and shows all the errors. Interpreter is only one error. That's it. Okay. Now, yes. Correct all the mistakes. Semicolon. Yes, here A plus B. Okay. Yes, next here. Yes, double quotation. Okay, next. Yes, brackets. After correction, recompile. Recompile. Still errors. So what is error? Here error. Okay. 14th line. Yes, you're expecting for some comma. Expected the brackets, comma, right? This is okay. Yes. Compile this is, yes, correct that mistake. This is a mistake. Comma. Save and recompile. Yes, still error message of printf. 8th line. Subtraction. Yes, semicolon missing here, semicolon missing. Save. Semicolon. Expected semicolon. Okay. Yes. Yes. Compiles. No errors. No errors here. Yes. After that, now you have to convert the exe file. Some project exe. Suppose ex name is, let us say, mnraw. Mnraw test.o. Test. That ex name can be anyone. ls. Mnraw exe file created. Dot slash. Just mnraw. Yes. That's it. Append the exe for converting the exe file. So this is exactly difference between interpreter and compiler. Okay. Yes. Let us see. Line space. Yes. We'll discuss very clearly. Yes. Last 5 minutes. Almost completed. Last 5 minutes. Wait for 5 minutes. Yes. Interpreter and compiler differences. Let us compare. Interpreter and compiler. What's the difference between these two? Interpreter and compiler. What's the difference? Okay. Interpreter. First difference. The interpreter. Yes. Checks the quotes line by line. Checking line by line. Not all this, only one line checking. It checks only one line here. Interpreter. Yes. All the statements. Interpreter checking all the statements. All statements. Case statements from top to bottom. From top to bottom. From top to bottom. From top to bottom. Okay. So compiler checks only one line at a time. After checking, immediately executes. But compile is not like this. First of all, checking complete program top to bottom, all statements from top to bottom. Okay. Next output, when once come to output here, yes, line by line. These are line by line. First line checking, if it is correct, generating output immediately. So output also line by line here, line by line. But compiler, see exe file, right? At a time executing exe file and giving output at a time. So at a time output, at a time output, at a time output, at a time output. Okay, right? Yes, next difference. Yes, if any error comes, interpreter stops. If any error comes, interpreter stop. That means it shows only one error. It shows only one error. It shows only one error. Compiler all the errors. It shows all the errors in the program. Compiler all the errors. Interpreter shows only one error. Compiler shows all the errors from top to bottom. All the errors from top to bottom, from top to bottom, top to bottom, top to bottom, right? Yes. Next, interpreter. Yes, directly program execution, no exe file. It does not generate exe file. It's a main difference. It does not generate exe file. Does not generate exe file. Does not generate exe file. Yes, company generates one exe file. Generates exe file. It generates exe file. Okay. So interpreter does not generate exe file. Compiler generates exe file. Compiler generates exe file. This is main difference. What's the main difference between interpreter and compiler? Okay, main difference is exe file. Compiler based language, this exe file. Interpreter based language don't have exe file. So interpreter does not generate exe file. Compiler generates exe file. Okay. Yes. Here, interpreter based, it executes source code directly here. It executes source code directly. Executing source code. See this. Executing source code, Python, the directly source code executed. Directly test.py is a source file. That source code executed directly. But compile exe file executed. So this one more difference. Yes, it executes source code directly here. Yes, compile base, it executes exe file. It executes exe file. Okay. Yes. Next here, interpreter based languages are called as scripting language. These are scripting languages. Interpreter based languages are called as scripting language. Compiler based are called as programming languages. Programming language. The programming language. Yes, interpreter based language, scripting language examples. Python is a best example. Python, HTML. Yes, next Linux shell scripting. Linux shell is the interpreter. Shell scripting is interpreter based. Python scripting, HTML scripting. So next shell scripting. Next PHP and Perl scripting. They are interpreter based language. Okay. So Python, HTML. Yes, HTML. Yes, suppose D drive. Yes. 1 second. Advanced Java. Yes, here HTML codes. Suppose some HTML code. This is HTML codes. Hypertext markup language. HTML codes. Here this is some yes login form. This is some login form. See, double click and open. So directly executing this is directly. Browser is the interpreter. Browser is the interpreter for the HTML. HTML is a browser understandable language. HTML is a browser understandable language. Browser is the interpreter. For HTML, browser is the interpreter. So like this interpreter based directly program executes. Interpreter based. Okay. So directly program executes. Okay. But compile based exe file. Okay. So these are interpreter based languages. Compile based examples. Compile based examples. Yes. C language. C is a compiler based. Next C plus plus compiler based. Next .NET C# is a compiler based. Right? Okay. Yes. What is Java? Is it compiler or interpreter? Depends on what. Depends on both. Interpreter as well as compiler. The topic we'll discuss. Next topic is Java, about Java only here. Okay. So next difference here. See interpreter. Yes, interpreter based language. Interpreter based language. Interpreter based language don't have exe file concepts. Interpreter based language don't have exe file concepts. Exe file concept don't have exe file concept. Yes, compile based everything is exe file. Here everything is an exe file. It's an exe file. So before running first exe generates. After generating exe then execution. But here interpreter based language don't have exe file concept. There is no concept of exe files. So this is a difference interpreter and compiler. The interpreter is line by line. Compiles all the statements at a time. Yes, interpreter shows only one error. Compiler shows all the errors from top to bottom. Yes, main difference is exe file. Exe file is a main difference. Interpreter does not generate exe file. Compiler generates exe file. This is a main difference. Okay, interpreter based. If the source code executes directly, compiler based exe file executes. Exe file executes. Okay. Yes, all scripting languages comes from this category here. Yes, interpreter based language called as scripting languages. Compiler based language called as programming languages. They are scripting language examples. Python is a scripting language, not a programming language. Python is a scripting language. Okay. C, C++, .NET. These are programming languages. Okay. What is Java? Yes, Java depends on both. The topic tomorrow we'll discuss. Tomorrow I'll continue for Java. So what is Java? Yes, we'll discuss. One second. Same topic explained in document here. Languages, language, low level language, high level language. Okay, generation of language tomorrow we'll discuss. Generation. See difference between compiler and interpreter. Today topic. Interpreter and compiler. All that different. That 8 differences. All the differences. What is Java? Java depends on both the compiler as well as interpreter. The Java topic. How compile interpreter? How depending here? That's the topic tomorrow will continue here. So tomorrow topic is about Java. Yes, starting Java tomorrow. About Java. Yes, about Java. Is it interpreter based or compiler based? Next features of Java. Next, yes, exe file dot. Tomorrow topic main focus on this area. Exe file dot class. What is exactly exe file? What is dot class file? Dot class file contains what? Exe file contains what? What's the difference? Tomorrow we'll discuss about this one here. So tomorrow topic is Java. Starting Java. Say about Java. Interpreter based and compiler based. Java both. How it is? How it is interpreter based and compiler based. Next about exe file dot class file. Next about that features. Tomorrow topic. So tomorrow starting Java. So till now, yes, all the basics completed. We'll start Java tomorrow. Yes, any doubts? Yeah, I'll share the document. This document for you only. Okay. Yes, I'll share it. Don't worry. This document for you only. I'll share it. I'll share in group, WhatsApp group. Okay. I'll share in the group. Okay. Yes. For your batch, already WhatsApp group created. Yeah, that's all for today. Yes, same link till Saturday. No change. Join the same link. Okay, till Saturday you have to register. That registration form you have to fill it. From Monday onwards, it's a go-to meeting link. With go-to meeting link, every day not necessary. Go-to meeting link. Once link changed to go-to meeting, that time need not submit your information. Only go to training. You have to fill that information and register. Every day required. From Monday onwards, go-to meeting link. Yes, for go-to meeting link, directly can join. Need not fill any information. Yeah, that's all for today. So thank you guys. See you tomorrow, same time, 10 o'clock. Right? Thank you. See you guys.